So let's do some problems with arc length and area of a sector. First, we'll start with some review. CD is the diameter, meaning then that it cuts our circle into two semicircles of 180 degrees. So this segment around here is 180 degrees, but it also tells us that arc CB is congruent to arc BD, so we know they are both the same. It has to be 90 degrees, 180 divided by 2. That also means these angles, because they're central angles, are right angles. We know that arc EC is 82 degrees, and 180 minus 82 will give us our other part of this arc, because this is also 180 degrees. Our diameter is 10. C is the diameter, it's 10, so our radius is 5. So let's go through these problems. Measure of arc BC is 90 degrees, as well as BD. Arc ED was 98. Angle EAC, this angle here, it's a central angle, same as the arc that it cuts off, so 82. And angle EAB, all the way here, is the sum of these two angles, so 82 plus 90, 172 degrees. Area of a circle. Remember that the area of the circle is pi r squared, and the circumference of a circle is pi, or 2 times pi r, or pi times diameter, however you want to think about it. In letter F, the area of the circle A, the radius is 5, so 5 squared, 25, and I want to leave pi in my answer because it's exact, and it's easier. 25 pi inches squared units. Circumference is pi times diameter, which is 10, or 2 times pi times r, 2 times our radius is 5, so either way, it's 10 pi inches. Now the length of arc CB, that's just this part here. Well, we know that measure of the arc is 90 degrees, so 90 out of a possible 360 times our total circumference, 10 pi, will give us how much of our circle that is. Our circumference is all the way around. We just want to find this part of it. 90 out of 360 is 1/4. So really it turns into 1/4 times 10, 2.5 pi inches. Area of the shaded region, this green, it's the same idea, 90 out of 360. However, now we're dealing with area, so it's the arc measure, 90 divided by the total number of degrees, 360, times the area of the circle, it's 6.25 pi inches squared. EC is going to be the same exact thing, except now we're dealing with arc EC, so it's 82 over 360 times its length, so we're dealing with circumference again. When we multiply that out, we end up with 2.28 pi inches. It's rounded, not exact like the other answers. Area of the sector, same thing, 82 over 360 times, now area, so 25 pi, that's about 5.69 pi inches squared. So it boils down to, and remember, a sector is the region of circle made by two radii, and an arc, really it's a piece of pie. It's that green area up there. So here are two formulas. This is what we're going to get on our formula sheet. Arc length is the measure of the arc divided by 360 times pi times d, or 2 pi r, our circumference, or we have our proportion. And the area of the sector is the measure of the arc over 360 times pi r squared, the area of our circle. So we'll do two quick examples. Number 11 here, we want the perimeter. We already know this 3, this 3, this 5, and this 5. So 3 plus 3 plus 5 plus 5. We already know 16. We just got to find these parts. Now, we know they're all the same, so we just have to find one and multiply it by 4. But notice 150 is this outside angle. We want the inside angle. 360, 150 will give us 210. That'll be the inside angle. So 210 over 360 times the circumference of our circle, because we're finding perimeter. We're finding distance. So our circumference, again, is 2 pi r. In this case, it's 2 times pi times my radius, 2, 4 pi. So when we do 210 divided by 360 times 4 pi, we get about 2.3 repeated, actually, pi. But we got to multiply by those by 4 because there's 4 of those little arcs. We got one here, 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 and here, and they're all the same. So we multiply that out, we get 11.7 pi. And we're just going to keep pi in our answer, so 16 plus 11.7 pi. Oh, sorry, I multiplied that wrong. It's not 11.7. It's 9.3. 9.3 pi, and there is no units, we'll just say units. Now over here, number 9, we did one like this in class. This shaded region on the bottom is just like this. So we're going to find the area of that blue part, and we're going to subtract off this green. So we're just looking at the top half of our circle. So we're looking at a semicircle. So we have 2 circles we got to deal with here. We want the area of the big sector minus the area of the small sector. So the area of the big sector is 1/2 pi times our radius squared, because again, area of a circle, pi r squared. Now the big radius, this is 4, this is 2, so we have 6 squared, minus the smaller part. Well, the radius is just 4 there, it's still 1/2. And again, it's 1/2 because it's really 180 degrees out of 360. So 1/2, we just simplified it. So we get 1/2 of 6 squared, which is 36, 18 pi, minus 4 squared, 16, 1/2, that is 8 pi. And up with 10 pi centimeters squared because we're dealing with area.